through instructions. Yeah, this problem is really easy to understand, and it's also easy to do if you use the right data structures. So let's first try to understand the problem. So we are given an array of instructions, and you are asked to create a sorted array from the elements in instructions. You start with an empty. So for the first example, we are starting with an empty array. Now we are going to insert the element inside instructions inside our array nums. Yeah, we are beginning with an empty array. Now we're gonna insert 1 inside the nums. Yeah, so if we insert 1, we need to find how many elements which is smaller than 1 and how many elements which is bigger than 1. So currently, after we inserting 1, there's no element smaller or bigger than 1, so it's gonna be the minimum of 0 because we want to choose the minimum value, and our final result should plus this 0. And secondly, we're gonna insert 5. Yeah, because there are only 2 elements. Normally you should understand if there are only 2 elements, it is not possible. Yeah, and how many elements smaller than 5? It is 1. And how many elements bigger than 5? No, it is 0. So 1 and 0, it is 0. Now we're gonna insert 6. Similarly, there's no element bigger than 6, so it's gonna be the minimum of 2 and 0, so it is 0. And then we're gonna insert 2. So after inserting 2, how many elements smaller than 2? It is 1. How many elements bigger than 2? It is 2. There are 2 elements, so we're gonna choose the minimum. So finally, we're gonna sum up all those values, so the final result is 1. Yeah. After analyzing of the first example, I think you've already found a solution. You just need to choose a data structure to solve the problem. So for me, in Python, I'm gonna use a sorted list. Yeah. Because the sorted list, after insertion, all the elements inside the nums would be sorted in increasing order. After in increasing order, I'm gonna use a binary search to check how many elements bigger than 2 or smaller than 2. Yeah, and then I'm gonna choose the minimum. Yeah. But there is also duplicate. I think the hard part is about the example 3. Because there are duplicates, we need to think about how can we avoid the duplicate element. Or if there are duplicate elements, how can we count the duplicate element and make the result totally exactly like that. Yeah. So I'm gonna explain this example 3 later inside my code. Now let's just start coding. So I'm gonna use a sorted list. So from sorted containers, I need to import the sorted list. Yeah. Sorted list. So I'm gonna prepare the sorted list. So the sorted list would be just a sorted list. Now I'm going to check the instructions one by one. Yeah. So for I inside the instructions, this I is just an integer. So for my sorted list, I gonna add this element inside my sorted list. So sorted list should add this element I. Yeah. So for example, from the beginning it is empty. Now I've added an element 1 inside. Yeah. But for this sorted list, I don't need to start from the beginning. I can only start from the while the length of the sorted list is more than 2. So for example, if it is 1, 5, so the result should also be 0. If there are 3 elements, maybe I can have a result, or maybe it is 0. But I'm gonna start from the 3 elements. It means if the sorted list, the length of the sorted list is more than 2. Yeah. So for this example, it is 0. Yeah, but there's no better examples. But for example, if the third element is not 6, if it is 4, so it means I've already got a result 1. Yeah. So this is why I'm gonna check from the length of the sorted list. If it is more than 2, I'm gonna check the result. Maybe I can get a minimum value. Yeah. But how can I get the position? So for example, if if I put 1 and 5 inside, next I've got a 6, and I've also put the 6 inside my sorted list. Yeah. So this I is just a number. It's not index. So yeah, maybe I can use a number n. Maybe you can understand it better. Yeah, because n is just a number. So I put the numbers inside the sorted list. If this sorted list is more than 2, it means I've already add 6 inside my sorted list. Yeah, currently I have 1, 5, and 6. I can use this value, this 6. I can use a binary search to check what is the closest value to this 6. Yeah, because if I can use this closest value, I can find. Yeah, just let me make it easily to understand. Yeah, if I insert 6 inside, I just need to find how many elements which is smaller than 6, how many elements bigger than 6. Currently, there are 2 elements smaller than 6 and 0 element bigger than 6. Yeah, I just need to calculate it like that. Yeah. Let me use index j should be equal to bisect. Yeah, I'm gonna use the sorted list because sorted list also can use the bisect left. Yeah, so the SL bisect left, SL dot bisect left with a number. So this number gonna be my current number. Yeah, even I added it inside, but I can still use it because it's gonna be easier for me to solve the problem. Yeah. Yeah, I'm gonna directly check this number. This number is n. Yeah, so for example, if I use this number n, it is 6. So the index for this j would be 2. So how many elements smaller than 6? There are 2 elements. Yeah, because according to the question, all the numbers inside, yeah, let me think about it. Yeah, if I put a 6 inside, all the elements before the 6 should always be unique. You need to understand it like that. Yeah, because even here maybe a 6, but all the elements before this 6, 1 and 6, they are unique. There's no duplicate numbers at the left of this number. Yeah, this is the properties of the bisect left. So this means from the left side there are 2 elements smaller than 6. Yeah, because bisect left is always bigger than the previous element, bigger and equal than the previous element. Yeah, more than and equal than the previous element. This is why we are sure there must be 2 elements smaller than 6. So we can get a minimum value. So the minimum would be the minimum of the left side and the right side. So from the left side, we are sure it is j element. Yeah, let me check if it is a j or yeah, if I check this is 6. Yeah, so from the left side there must be j element. Yeah, because this index is 2, so I can use this 2 directly. Yeah, and how many elements at the right side of this 6? So it's gonna be the length of the sorted list. Currently, yeah, for this one it is 3. Yeah, so the 3 should minus j equals to 2. It is 1. We should still minus a 1. So this is just mathematical calculations. You need to understand it like that. Yeah. So what is the final result? The final result is just you need to use your result plus equal to the minimum number. Finally, you just need to return the result. So let me prepare the result to be 0 from the beginning. Now we are sure this example and the second example should always work because there's no duplicate numbers. If there is duplicate numbers, I will analyze it later. Yeah, let me just run it to check. Yeah, as you can see, it works for the first and second example, but it didn't work for the third example. Yeah, because there are duplicate numbers, we need to think about how can we solve or handle the duplicate numbers. Yeah, as you can see here, the expected result is 4, but our output is 6. Yeah, this is because of the duplicate numbers. As you can see, there are so many 3. So we're gonna analyze the duplicate numbers. Yeah. So for example, currently before we have a state of like 1 2 3 3 3. Yeah, I think I'm gonna use a better example. Yeah, I'm gonna use this example maybe. Currently I have 3 numbers, 1 3 3, and next I'm gonna insert 3 inside. Yeah, but where is the position? You should know about. If I were to insert 3, it should be at this position. I mean the second number, index 1. It is because it is bisect left. Yeah, I need to handle this case. Now let me make it here. Yeah, you need to understand how can we get the result from this array to the second array. Yeah. So we're gonna prepare some data structure to solve the duplicate numbers. So from the left, it should always work. So for example, if we insert 3 from this array, so the 3 would be here, and this j should be equal to 1, and how many elements smaller than 3? It is 1, so it is this index j. But let's just check this one. It is the length of SL. It is 4 minus j minus 1. It is 3 minus 1. It is 2. Yeah, but our result should be 0 because there's no element. There's no element bigger than 3. Yeah, so this is why it is wrong for the result. So what kind of data structures can we use to solve this kind of a problem? Yeah, so it means for each of the iteration, we need to store how many 3s. Yeah, how many 3s inside the dictionary. Yeah, so we can add a 3 inside our sorted list, but we also need to record how many 3s. So currently, we need to know there are 2 3s inside of the dictionary before we add in this 3. This 3, we just added it, but we need to know how many 3s before we add this 3. So there are 2. We need to record these 2 numbers of the 3. Of course, we can use a dictionary. So let me just use a counter. So say would be equal to a counter. But we need to add this number at the end of the line. It is not before. Yeah, because after executing all those lines, yeah, we got a 1 3 3, and we need to count. There are 2 3s, so it means after executing this line, we're gonna use the counter to add it to the result. So it would be say n plus equal to 1. Yeah, as you can see, it is just 2 lines, and it makes our problem really easy. Yeah, if you don't understand, you just need to use try to use more examples. Yeah, because from here we need to record there are 2 3s, and from here, after put it inside, so we're gonna use this formula. Length of the array, it is 4 minus j minus 1 minus 1, it is 2, and we need to minus this say n. This is C3, it is 2, so it's gonna be 0 at the right side. At the left side, it is 1, and the result would be 0 for current situation, for the current execution from this array to the next array. Yeah. Now let me just run it to check if it works. As you can see, it works. Yeah. Now let me submit it to check if it can pass all the testing cases. Yeah, I hope it can pass. Yeah, let's just check. Yeah, this is why I think this is gonna be a really big number. Maybe there's a modular, I forget about it. Yeah, there's a modular, I forget about it. We should always use this mod, so the result should be, yeah, I need to be careful about reading the problems. Yeah, so I need to prepare the mod. So the mod would be 10 to the power of 9 plus 7. Yeah, because it's gonna be a really big number. Now let me just run it to check if it works. Yeah, as you can see, it works. The time is just so slow. I didn't expect it. It is not so slow. So yeah, it is 73%. 2 seconds is still okay because n is 10 to the power of 5, and n log n would take time for Python. 2 seconds is still okay. Yeah. Thank you for watching. See you next time. And by the way, this reading is just 2200. Yeah, normally for this kind of questions, the readings would be like 1800 or 1900. Yeah, or maybe, yeah, maybe if you use some difficult data structures like balanced tree or binary indexed tree or segment tree, that's going to be a little bit harder. But basically, that is also the template. Yeah. Thank you for watching. See you next.